Hello students, and welcome again to today's lesson. My name is Mr. Knec, and welcome to my channel, that is eMaths with Knec. Kindly remember to subscribe, share and also comment. And very specifically, this is a very special lesson because you're going to be checking Knec revision questions, and particularly on this video we are looking at calculus, and that is differentiation from first principle. So July 2023. So now differentiate the function fx given this quotient from the first, or using the first principle. Now let's check the solution. Now, so what does the first law rule state? So the first principle rule states if you want to find the first derivative, which is written as prime, is given by the limit as h tends to 0. Then you have fx plus h, then minus f of x, then divide by what? Divide by h. So therefore, this basically means every place you have an x, you'll be adding a h in our respective variables. Then you subtract the original function, then you divide with h. So therefore, in putting this, so we have, now writing this, we have f prime x is given by limit as h tends to 0. So our function, remember, it's a quotient by the end of the day. So we have the top and the bottom, so we shall have 1 plus. So we are saying where we have an x, we add a what? A h. So therefore we shall have 1 plus x plus h all over 1 minus then x plus h, right? Then we subtract the original function, which is this. So 1 plus x divided by 1 minus x. Then you divide by what? Divide all these by h. So now we have a property that we know. Remember, this is a fraction, this is another fraction, and we have our denominators not being the same. The numbers are not the same. If you can remember, if you have 1 over 3 plus 1 over 7, for example, 3 and 7 do not share anything in common. So basically, the LCM will be the multiple of this and this. So the LCM will be 21. Then 3 will go into 21 7 times. So you'll multiply by 1, which gives you 7. Then you have 7 into 21, which will go 3. Then 3 times 1, which will just be 3. Now, basically what you're saying, if you have these are fraction, and the denominators are not the same, their LCM will be the multiple of these two, numbers, okay? So let's apply that. And simplify our numerator. So we shall have limit as h tends to 0. Then we have, so the LCM is saying is the multiple of this and this. So it is 1 minus we have x plus h, so bracket, then we can put another bracket there, and we have 1 minus x. So that is our LCM. Then these will multiply this term and this will multiply that term. So we can expand this and we shall have 1 plus x plus h. You can say that is our term. Then now this multiply this term here, so we have 1 minus x. Then we can subtract. Let's have another bracket there. So it is this term, 1 plus x. You can put it under a bracket, smaller bracket. Then the whole of this term, you can expand it to multiply the other term. So expanding this, we shall have 1 minus x minus h, right? So then all of that, we divide by what? We divide by h. So that is our term. Now, by a certain law again, if you have a fraction, let's say 1 over 2 divided by 3, we know one thing. This can be written as 1 over 2 divided by 3, which is changing this one into multiplication becomes times what? 1 over 3, which is just 1 over 6. So what are we saying here? When you have a fraction here and you have a number, this number is can literally be dropped down. Okay? The term that is here can be dropped down. Now, applying the same in this one, you can drop this one as we expand our numerator. So expanding this. So remember this term, we can use the second term, and here you can use the first term. So this term will expand the whole of this, then this expands. So we expand the term at the top, so we have limit as h tends to 0. Always remember to put an equal sign showing a continuation, right? As h tends to 0, then we shall have expanding. So 1 times times everything inside the bracket there will just be the same. So 1 plus x plus h. Then x will negative of x now will multiply again the same, so everything will be negative there. So we'll have negative x times 1 is negative x. Negative x times x will be negative x what? Square. Negative x times h will be negative of x h. Right? You can bracket that. Then we have this term again there's a subtraction sign here. So we have minus, then into bracket. So this one again opens everything. So we shall have again 1 minus x minus h. Then x again multiplies everything. So we have x times 1, which gives you plus x. X times negative x minus x squared. X times negative h gives you negative x what? Negative x h. Then all over, you can have a bigger bracket, all of us, then this just drops down here. As you see, you can expand it also, so it is 1 minus x minus h. Then we have this term, 1 minus x, then we have our h. So this and this will be a denominator. Then from there, we open this bracket, so we have limit as h tends to 0, we shall have 1 plus x plus h minus x squared minus x h. Now negative times 1, negative 1, negative, negative plus x. Negative, negative again gives us negative, that will be positive. Will be positive of h. Negative, positive is negative of x. Negative, negative, it's a positive of x squared. Then negative, negative is a positive of x, is a positive of xh. Then all over everything there, 1 minus x minus h, then 1 minus x, then we have h. Now we can take like terms together, we add and subtract them. So we have a 1, we have a negative 1. That becomes what? Becomes 0. So this goes with that. We have an x, we have a negative x, so this positive and this goes. So then we have a negative of x squared, and we have a positive of x squared. What else? We have a h, and a h that will give you 2h. Let's see if there is anything else which can cancel this one, and this one also can cancel out. We have an x, and we have a negative of x. So basically you can see we have a h, and we have another h here, so it becomes 2h. So this one becomes limit as h tends to 0, then you have 2h, then all over 1 minus x minus h, then 1 minus x, then h. Now, this h will go with that h. So we have that. Then at this point, we can replace our value of h being what? Being 0. So putting 0 here, so we'll have 1 minus x minus 0, we'll have 1 minus x, then we'll have 1 minus x. So 1 minus x and 1 minus x will be the same term. So replacing with h being equals to 0, we shall have 2 all over 1 minus x minus 0, then 1 minus x. Then expanding this, we just have 2, then 1 minus x. Since this will remain as 1 minus x and this one is 1 minus x, we have square because there will be 2 of them. Therefore, the derivative for our function there will be given by 2 all over 1 minus x squared. So example 2, that is from November 2022 series. So we have the function y equals to 3 exponential raised to power 3x. So the solution. So so we can just rewrite this in terms of functional notation. So we can just say these are fx, which is now given by e 3x. From the law, from the first principle, we know, just write it here, we have f prime of x is given by limit as h tends to 0, Then we have what? Fx plus h minus f of x, then all over h. Now, writing this formula is so important because it keeps you on track, especially when you're replacing your values. So let us now rewrite this. So our f prime of x will be given by the limit as h tends to 0, so into bracket. So you have exponential 3, then where you have an x, in this first part you had a what? H. So you have x plus h. Then subtract the original function, which was e raised to power 3x, then you divide by h. Now this can be opened up, and we say the limit as h tends to 0, then into bracket e 3x plus 3h minus e 3x, then all over h. Now, from the laws of indices, when you have powers which have been added, it means we had a base, a common base, which had different powers, and the powers were added simply because the two terms were multiplied together. From this law, you have the law a m dot a n is the same as a m plus n. So we have that. So therefore, we can split this into two. Just a rewriting. So we have limit as h tends to 0. We have e 3x, then we have 3h, then minus e 3x, then all over what? Over h. So you can see we have an exponential raised to power 3x, exponential raised to power 3x, so we can factor it out. So we have limit as h, so equals to limit as h tends to 0. Then you can say this one is e 3x, which is common, so into bracket. So what do you remain with? You remain with the exponential raised to power what? 3h, then minus e. Now, do not be e because that is what you have removed outside. So you remain with 1 here. Then divide by what? Divide by h. Now again, from the laws of limits, we say the product of the limit is the limit of the product. So basically we can split these two into 2. So this LCM will go with this term, then the exponential of 3x will remain. So we can split this into 2 and say limit h tends to 0. We have e3x standing on its own, then limit of h tends to 0, then e3h minus 1 over h. Now, why do we put h together with what we have on h here? It's because we have a limit law which says if you have the limit, let's say as h tends to 0, exponential of x, we're using h, so exponential of h minus 1, then all over h. All of this basically gives you 1, okay? But now this one again translates from, if you have a limit as x tends to 0, and you have 8x, then you have minus 1, then you have over x. This one always gives you the ln of a, okay? So from limits, this one gives you the ln of a. But now, what is our a here in this term? Our a is an exponent, okay? And the natural log of an exponent, the natural log of an exponent is just what? It's just 1, okay? So now, what we are supposed to do here, at this step here, is just simple. We are supposed to make our power to be the same as the term that we have here. That is simple to do. What do you do? Just introduce a 3 here and multiply by 3. Because if you multiply a 3 and a 3 here, this 3 cancels with that. And again, since this one is a constant, the constant can be removed outside. So we shall have limit exponent 3x, then h tends to 0, okay? Then multiply by this 3 can come here, then the limit as h tends to 0, e 3h minus 1, then we have 3h. So therefore, we say the whole of this gives you what? It will give you 1. Alright? So the whole of this gives you 1. Now, this one again is a constant. Now, we don't have a variable h here. When you are taking the limits and you don't have a variable in which our value is tending to, then this value here just becomes the value that you have here. So we don't have an h here. So basically here we shall remain with what? We shall remain with e 3x and multiply by what? By 3. So therefore we shall have 3 exponential raised to 3x, and that is your derivative of e raised to power 3x using the first principles. So we can take another example here, that is a trigonometric function, that is the sine of what? Sine of x. Now, so solution. Now, before we check this, there's some two limit laws that you need to know. And one, we have this limit law that when you have the limit as h tends to 0 of sine of h, then divide by h, this one will be given, the answer is always 1. Then 2, limit as h tends to 0 of cosine of h minus 1 over h, this value is always 0. So these are very important things that you need to know as you progress in this question. So now let's check. So from the first principle we know that our f prime of x will be given by limit. So we have the limit. We have the limit as h tends to 0. Then we have f x plus h, then minus f of x, then divided by h. So we have that. Now replacing our values, so we have a function that is, we have 0. Now it is sine of x, so when we have an x, we add what? H. So we have sine x plus h. Then subtract the original function, which is given by the sine of x. Then you have divide by what? Divide by h. Now we want to expand our sine x plus h, right? We can expand our sine of x plus h using compound laws, trigonometric laws. So using the compound laws, so we have the sine of x plus h. This one can be expanded as sine of x, then cos of h minus, it's a plus, so it is a plus there. Then we have cos of x sine h. So you have a law where you have now here as a and b. So the first term is sine of x, then cos of h, then you interchange your values. So you'll have now again cos of x sine of h. So this term will be expanded as this. So we have, therefore, we have limit as h tends to 0. Now the whole of this becomes sine of x cos of h, then plus cos of x sine of h. Then you subtract the sine of x, then you divide by what? Divide by h. So we have that. Now we can take the term that has something in common. So we have a sine of x cos of h, we have sine of x sine of h, and we have sine of x. So you can see we have a sine and we have a sine here, right? So this term and this term can be put together. So we can have limit so that we can factor out the common term. Now bringing the sign here, okay, let's just first of all write it, cos of h, then minus sine of x, then this term here, then cos of x, sine of h, then all over h. So then from there, factor out your sine of x and sine of x from this. So we shall have the limit as h tends to 0. Then we have sine of x is common. So what do you remain with? Cos of h. Then since you have removed the sine of x, so you have what? Minus 1. Okay. Then we have this term, then plus cos x sine of h, then all over h. Now, again, from the laws of limits, we say the sum of the limit is the same as the limit of the sum. Okay. Now, we have this, so we can split. Since we have an addition here, you see this one term now already, and you have another term, so we can split them into two. And since this one is an LCM, remember, if you have 1 over, let's say 1 over 2 plus, let's take another number, maybe 3 over 2. The LCM of this and this is the same, right? Which is just 2. Then you have the terms at the top. So we are saying this h will be shared in this term and this term. So we have this. You can assume this term as this. So we can come from this side to this side, but we have the h being shared. Okay. So we split now. Limit as h tends to 0. Then we have sine of x into bracket cos of h minus 1. Then all over h, then bracket that, then plus the limit as h tends to 0, then you have cos of x, sine of h, then you have h. So we have that. Then we can again this one becomes a multiple. We are multiplying this and this term. Again, the product of the limit is the limit of the product. So split this since you have a multiplication. So we'll split and we have limit as h tends to 0. We take the first term. Now remember here, this term will not be shared. So we'll take our term here because we're splitting them. So this h will go with the term that has a h. The same here, it will go with the term that has an h. So we'll have sine of x. So the first one will just be the sine of x. Okay. Then the second one multiplied by the limit as h tends to 0 of this term now, cos of h minus 1 all over h. So this term here splits into 2. Then the same happens here. We have the limit as h tends to 0. So we can put that into a bracket. Okay. Then split. So we have cos of x. So that is the first. Then multiply by the limit as h tends to 0, then we have sine of h over h. So we have that. So you can see we are just splitting the terms. Now, let's take this. Do we have a variable x here? No. Do we have a variable h here? No, we don't. So our term here basically remains as the sine of x. Sine of x. Multiply by. So what did we say from our limit rule? That this will give you what? It will give you 0. So you'll have multiply by 0. Then plus. Do we have a h here? No. So we'll have what? Cos of x. Then this term here will give you what? This one will give you 1. So you multiply by 1. So anything multiplied by 0 is what? 0. Then 1 times the cosine of x is just the cosine of x. So 0 plus the cosine of x just gives you what? The cosine of x. And that is the derivative for the sine of x using the first principle.